Here's part B of number 3 from the 2014 AB and the BC exam. And we have a graph of f provided to us here. They define this function g to be a definite integral that involves the function f. And then in part B it says on what open intervals contained between -5 and 4 is the graph of g both increasing and concave down. So I'm going to see if I can just kind of figure out what these two things mean before we go about any work. So a function is increasing when its derivative is positive. If g is increasing, that would mean that g prime of x is positive. So we want to know not only where g prime of x is positive, but places where g prime of x is positive where the function also happens to be concave down. Well, concavity is determined by the second derivative, and the second derivative of g would be denoted by g double prime, and if we are looking for intervals where we're concave down, we're going to be looking for where g double prime is less than 0. So essentially we want to specify all intervals between -5 and 4 where g prime is positive and g double prime is negative. Now before we can find those, we're going to need to find g prime and g double prime. So g of x is written right here, and to find g prime of x, what we can use is we can use the second part of the fundamental theorem of calculus. And if you remember that as a derivative formula, the second part of the fundamental theorem of calculus says to take the derivative with respect to x of a definite integral where x is the upper limit of integration. All you need to do is replace the t, the value that's within the integrand here, the variable there, with that upper limit of integration. So the second part of the fundamental theorem of calculus essentially says that derivatives and definite integrals in this specific fashion are going to undo each other, and we're just left with the integrand with the upper limit of integration in place of the t. That's all that happens here. To take the derivative of g, we're going to take this upper limit of integration x, we're going to put it in place of the t. So g prime of x is simply going to be f of x. There's nothing else to it. Every once in a while you might have to use a chain rule. If there's like an x squared or more than an x right there, since you are taking a derivative and you'd have a tiny inner function in that spot, you might have to multiply by the derivative of the inner function. We can do that here. The derivative of x is 1. It doesn't really affect us at all, so I'm just going to go back and get rid of it. So there's g prime of x. What I think I'm going to do right now is I think I'm going to build a quick sign chart for g prime of x. And the sign chart needs to hold for the open interval from -5 to 4, so that's what those open circles are denoting. And I would need to know that, well, g prime of x is obviously equal to f of x, but if I'm looking for the sign of g prime of x, I would need to know when g prime is 0, when g prime is undefined, at any x values between this one and this one. Well, when is f of x undefined? Well, look at the graph. You don't have any holes or asymptotes on this graph between -5 and 4. F of x is always defined, but f of x is 0 at this x value and again at this x value. So those x values would be, let's see, -3 and +2. So the sign of g could potentially change as we cross the x value of -3 and then again as we cross the x value of +2. Now, f of x is equivalent to g prime. If we want to know the sign of g prime between -5 and -3, we're looking at positive values for f of x there. So we're looking at a positive value for g prime. We're looking at positive values here too. Those values are all above the x-axis. Now on the other side of 4, we're looking at negative values. So we go positive, positive, negative for the sign chart for g prime. And what we know is that g prime is increasing from -5 clear up to 2. So we're increasing from -5 to 2. Now we also want to know when when g is concave down. So that's going to depend on g double prime. Well, if g prime is equal to f, taking the derivative of g prime gives you g double prime. Also take the derivative of this side of this equation over here, and you end up with f prime of x as what g double prime is. If we do a quick sign chart for g double prime, whoops, so it's supposed to hold from -5 to +4. There we go. We would need to know when g double prime is undefined and when g double prime is 0 between this number and this number. Well, f prime, which is equivalent to g double prime, f prime is always either a negative value, the slope of this line is negative, positive slope, and then negative slope. So f prime is never 0. But f prime is undefined twice. F prime is undefined at this location right here. The slope of the tangent line changes instantly from a negative to a positive. It doesn't have a nice smooth transition, so the one-sided limit that we would define a derivative with would not exist as we approached -3. So f prime is undefined at -3. F prime is also undefined at 0. So these two cusps on the graph of f are where f prime is undefined and equivalently where g double prime is undefined. Now what's the sign of g double prime on each of these intervals? Well, to the left of -3 we have negative slopes right here. So f prime is negative and so is g double prime. On this interval we have positive slopes. F prime's positive, as is g prime, and then on this interval we're back to a negative slope. So our function is concave down from -5 to -3, and it's concave down again from 0 to 4. Now we want to know where we are increasing, which happens here and it happens again here. We want to know where we are both increasing as well as concave down. Well, we definitely are both things from -5 to -3. So one interval that's a subset of this interval where this happens is from -5 to -3. We're concave up from -3 to 0 though. We increase clear until 2, and we are concave down from 0 to 2. So we would be both increasing and concave down from -5 to -3, and then also from 0 to 2. Now what's the reason for your answer? I'm not going to write this out, but I think I verbally stated this earlier. The reason why we are increasing and concave down on these intervals is because those are the intervals where g prime is positive and g double prime is negative.